Welcome everyone. Today we are discussing the elephant in the room regarding generative AI. Every enterprise currently has a generative AI prototype. Usually it's a 50-line Python script using LangChain, running locally that was the board of directors. But when you are tasked with moving the prototype into production, you suddenly hit a massive wall. You are confronted with data privacy laws, unpredictable token latency, massive cost overruns, and the terrifying reality of hallucination management. In this session, we are going to tear down the prototype and rebuild it using enterprise grade architecture on AWS. We will focus on the actual mechanics of scaling retrieval augmented generation or RAG securely. Why does the transition from prototype to production fail so often? Because LLMs are inherently non deterministic and stateless. In a prototype, you don't care if a response takes 15 seconds. In production, an e commerce chatbot with a 15-second delay or latency is a failed deployment. Furthermore, token economics scale linearly. If your application suddenly goes viral, your API costs can bankrupt your project overnight. Finally, we have the security boundaries. If you are retrieving enterprise data to feed into an LLM context window, you must guarantee that a user A cannot prompt inject their ways into seeing user B's secure data. This requires a robust cloud native architecture, not just a simple API call. Let's look at how we got here. In 2022, everyone was just calling external APIs. The models hallucinated wildly because they didn't know your enterprise data. In 2023, the reaction was we must fine tune our own models. But fine tuning is extremely expensive, requires massive MLOps maturity, and the moment the training finishes, the model's knowledge is already outdated. Today, the industry standard is RAG, or Retrieval Augmented Generation. Instead of teaching the model your data, you search your enterprise data in real time, retrieve the relevant paragraphs, and inject them into the prompt. RAG gives you a real time accuracy, it respects your existing database permissions, and it's drastically cheaper than fine tuning. Here is your reference architecture for production. At the edge, we have standard API gateway and EKS or Lambda. The actual intelligence layer is abstracted behind Amazon Bedrock. Bedrock is a fully managed service that gives you the access to models like Anthropic's Claude or Meta's Llama 3 via single API without managing the underlying GPUs. For the data, documents are stored in S3, processed, and their embeddings are stored in Amazon OpenSearch serverless, acting as a highly scalable vector database. Crucially, all of this traffic stays on AWS backbone network via private link. Your data never traverses the public internet, and it is never used to train the base foundation models. Amazon Bedrock is the core component here. The most critical architecture decision you can make right now is to build model agnostic systems. The best model changes every few months. By using Bedrock, you abstract the model layer. You can route complex reasoning talks to Sonnet 3.5 to 4.7 and simple summarization task to a much cheaper model like Llama 3 or Amazon Titan. For true tier 0 enterprise applications, relying on on-demand throughput is risky. You will get throttled during peak hours. You must purchase provision throughput to guarantee your latency SLAs. Finally, Bedrock guarantees that your proprietary prompts and corporate data are not used to train the underlying models. As we said earlier, the LLMs are stateless. LLMs have no memory. The vector database is how we give them long term memory. Traditional relational databases use lexical search. They look for exact keyword matches. Vector databases use semantic search. We pass our enterprise documents through an embedding model, which turns paragraphs into arrays of thousands of numbers. When the user asks a question, we turn their questions into a vector and then find the closest match in the vector database in a mathematical space. Amazon OpenSearch Serverless is the enterprise choice here because RAG workflows are notoriously spiky. You might ingest a million documents on Monday and do heavy reads on Tuesday. Serverless handles the underlying shard scaling for you. Let's trace a live request. A user asks, "What is our Q3 refund policy?" First, the API gateway authenticates the user. We must turn the text question into a vector listing using an embedding model. We query OpenSearch with that vector to find the top 5 paragraphs in our corporate wiki about refunds. The next step is crucial: prompt assembly. We dynamically build a massive string containing strict system instructions, the user question, and the 5 retrieved paragraphs. In the subsequent step, we send this massive payload to the LLM for inference. Because the process involves multiple network hops, we must stream the output back to the user at the end of the last step to maintain the perceived performance. Scaling GenAI is expensive. If 1,000 employees ask your internal bot, "When is the company holiday?" and that question is passed through a RAG pipeline and an LLM 1,000 times, it's a massive waste of compute and money. You must implement semantic caching using Amazon Elastic Cache with vector search support. We cache the embedding of the user's question and the LLM response. When employee number 2 asks, "What dates are the company holidays?" the exact wordings are different, but the semantic meaning remains the same. The cache detects the high similarity score and returns the cached answer instantly. You bypass the LLM entirely, cutting cost by up to 90% for common queries and reducing latency to milliseconds. What happens when Anthropic or AWS experiences a regional capacity constraint? If you're relying solely on US East 1, your application goes down. For Tier 0 reliability, you must implement cross-region inference profiles in Bedrock, allowing requests to seamlessly route to US West 2 if the primary region is saturated. Furthermore, you must implement model fallbacks in your application code. If your primary heavyweight model times out, your code should automatically retry against a smaller, faster model like Haiku. Finally, use circuit breakers. If the API is failing, fail fast and return a graceful error to the user rather than hanging your server threads waiting for a 60-second LLM timeout. Security is number one blocker for enterprise AI adoption. First rule: the LLM itself cannot enforce permissions. Security must occur at the retrieval layer. If an intern searches for payroll data, OpenSearch should return zero results based on their IAM or role-based access control tokens. Secondly, we utilize the Amazon Bedrock guardrails before a prompt reaches the model. Guardrails evaluates it for prompt injection attacks. On the way out, Guardrails evaluates the LLM's response. It can automatically redact PII data or block the response entirely if the LLM starts discussing a competitor or violating any corporate policy. This provides a deterministic security layer on top of a non-deterministic model. In traditional software, if an API returns 200 OK in 50 milliseconds, it's healthy. In GenAI, an LLM can return a 200 OK in 2 seconds, but the text might be a complete hallucination. The standard application performance management is not enough. You must implement specialized LLM observability. You need to log token counts to track exact cost per user or per tenant. You must track time to first token, which dictates user experience. Most importantly, how do you measure accuracy at scale? We use a pattern called LLM as a judge. We run a background process that samples production logs and scores the primary model's answers against the retrieved data to automatically detect hallucination. Furthermore, you must evaluate your retrieval pipeline independently of your LLM using traditional search evaluation metrics like mean reciprocal rank MRR and NDCG ensures that VectorDB is actually returning the right chunk before the LLM ever sees them. Furthermore, you must evaluate your retrieval pipeline independently of your LLM using traditional search evaluation metrics like mean reciprocal rank or MRR and NDCG ensures that the vector DB is actually returning the right chunks before the LLM ever sees them. As architects, we must ensure guardrails against bad engineering patterns. The most common anti-pattern today is the giant context window trap. You will hear people say RAG is dead because models now support 2 million tokens. This is an illusion. Dumping an entire 200-page manual into a prompt for every user request is a massive mistake. It costs significantly more per request, increases the latency to 30 plus seconds, and model frequently fail to recall information buried in the middle of massive prompts. You must force teams to use RAG. Another anti-pattern is naive chunking. If you just split documents by character count, you cut sentences in half, destroying the semantic meaning. Once you move past the prototype phase, you will find that naive chunk and surge RAG has a ceiling. To reach enterprise accuracy, you need advanced techniques. It starts with data prep. Don't use LLMs to parse PDFs. Use robust Python libraries to convert them to clear Markdown. You also need continuous research and development on your chunking strategies and your encoder models. At runtime, we optimize the query. Users ask terrible questions. Use a fast LLM to rewrite or expand their questions into multiple optimized search queries. After retrieval, pass those chunks through a re-ranker to select only the highest quality context. Finally, for complex datasets, consider hierarchical RAG for top-down summarization or graph RAG to preserve relationships among documents. Where are we going next? Standard RAG is evolving into agentic RAG. People say RAG is dead, but behind the scenes, an agentic workflow is just a much smarter RAG. Instead of a hard-coded pipeline, we give LLMs tools the ability to dynamically query SQL, do vector lookups, invoke APIs, and manage memory to solve a problem. However, letting an LLM autonomously trigger internal APIs is dangerous. You shouldn't rely on brittle Python orchestration framework for this. The enterprise pattern is using AWS step functions to orchestrate these agentic flows. Step functions provides stateful, resilient workflows where you can enforce a human in the loop pattern. The agent can draft a refund execution, but step function halts the workflow and sends a Slack message to a manager for approval before the API fires. To summarize our masterclass, do not let your teams build tightly coupled prototypes. Abstract your intelligence layer using Bedrock. Rely on RAG or retrieval augmented generation as your primary pattern for enterprise knowledge and strictly enforce security at the vector database level, not in the prompt. Finally, treat token consumption like an infrastructure bottleneck. Implement semantic caching early, or your GenAI features will become a massive financial liability. By structuring your system this way, you can transition from a fragile science experiment into a hardened cloud native enterprise platform. This is the end of the episode. Thank you for watching. If you like the video, please like, share, subscribe, and press the notification bell icon for future updates. This is your host Bhavesh Kumar signing off.